morning Year 10s. What we're going to do today is we're going to look at reaction rate. So if you just want to look at the board for a moment, we're going to look at the effect of the concentration on reaction rate. And the concentration that substance that we're using today is called sodium thiosulfate. Now we're going to combine sodium thiosulfate with hydrochloric acid. What's going to happen with that is that we're going to get a precipitate. So we're going to get some solid material coming out, which is our sulfur. So to us, that's going to look like some cloudiness in the solution. We also do get some sulfur dioxide, which we won't see, that's a gas, and we'll get some sodium chloride in the solution as well. Just looking at the equation, which you'll have with your handout anyway. So we've got the sodium thiosulfate, and we've got an AQ in the brackets after here, which means that it's dissolved in solution. Same with our hydrochloric acid, it's in solution, as is our sodium chloride. Just a word on independent and dependent variables. The red here that I've got written independent variable, that is the one that we as the experimenter are changing. So we're actually changing the concentration of the sodium thiosulfate. What we're actually going to measure, and we're going to do this by measuring time, is the reaction rate. Now the variable that we measure is called the dependent variable. Okay, so let's get started. I'll explain to you what we've got on the bench here. I've prepared some solutions already, just so it makes it a bit easier. This is our sodium thiosulfate, just a clear solution. It looks, nothing, any different to a water solution, but obviously it is quite different. In our measuring cylinders, we have a different amount of it. So we've got, in the first one, we've got 50 mils, 40 mils, 30 mils, 20 mils, and 10 mils. Now, what we want to do is when we do our reaction, we want to have a total volume of 50 mils in our conical flask. So be checking out all the equipment, because you need to be writing up a method for this practical. So our conical flask is going to have 50 mils total of reactants in it. Over near the tap here, we've got some water measurements made up. Now, we've put these here because we're going to actually do some dilutions with some of our solutions here. I might just start the first one just so that we get an idea of what's going on. Now the way we're going to measure this is we're going to put a cross with our whiteboard marker. So it's going to have a little cross there. We're going to put our conical flask over the top there. Now the way we're going to measure this reaction is that what we want to do is see how long it takes for, if we look down the top of that conical flask, how long will it take for that cross to disappear? Now what that means is that the solution gets so cloudy that we can't actually see through it. So, I talked about our thiosulfate, talked about our water to dilute. The other component that we're using is our hydrochloric acid. Now, each time we're going to add 5 mils of hydrochloric acid. So the only thing that changes in our experiment is the concentration of the thiosulfate solution, because we will gradually water that down or dilute it. So let's just have a try with our first one. So we've got our cross on our tile, we've got our conical flask, we've got a stopwatch here, and we have our first solution that we're going to use. Now this is just 0.2 molar sodium thiosulfate. So I'm just going to pour that into our conical flask. So that's 50 mils of sodium thiosulfate. We're then going to take our 5 mils of our hydrochloric acid, which was 2 molar. Now when I'm saying those molar solutions, that tells us how many particles of the hydrochloric acid is in there. Okay, as I pour this into the flask, I'm going to start my stopwatch so I can have a measurement of how long it takes before the solution gets so cloudy that we can't actually see that cross. So I'll try and do this at the same time. I can gradually see it starting to precipitate now. It's getting quite cloudy in the solution. And stop. Okay. If you can see that the solution's actually got quite a milky look to it now, that solid substance that's in there is actually the sulfur. Now that has made that solution so milky that we cannot see through the glass to see the cross on the tile there. Now that took 23 seconds to react. In a moment we're going to go on and gradually dilute the solutions, and we'll see what difference we can see in reaction rate time. Okay, so we've done our first measurement, so now we're going to go on with gradually diluting the concentration of the thiosulfate. We have 40 mils of thiosulfate measured out in a measuring cylinder here. The way we're going to dilute that is we're going to add 10 mils of water, pre-measured here, into the solution here. So compared to the first solution that we were using, we now have less particles of the thiosulfate solution in here. So think about what you might be expecting from this reaction when we do this. Firstly, we need to, so that's our thiosulfate. We need to get our hydrochloric acid measured out. We always use 5 mils of hydrochloric acid. We don't want to vary that. The only thing that we're varying is the thiosulfate solution. Best to undo this first. Can be a bit tough. Okay, so we've got 5 mils. Same thing again, going to pour this in and start the stopwatch immediately. And let's see how long it takes before we can't see that cross again. And obviously we'll have this one in as well. Oops, hang on, I need to reset that. Just mucked up, haven't I? Okay, let's go again. Okay, so we're looking and waiting for that precipitate to form and seeing how long it takes us this time. I can see it starting to get quite cloudy now. I can still see the cross though. And no. Interestingly, that one has taken a similar time to the last one. So that'll make for an interesting graph. Probably we would expect a different measurement, but that's okay. That's what happens in practicals. So in a moment, we'll continue to dilute the solutions. Remembering that this one was 40 mils of thiosulfate with 10 mils of water. Our first run was just thiosulfate, 50 mils. Now please take note that every time we have solution in here, it always adds up to 50 mils. The only thing we change is the ratio of the thiosulfate to the water. Okay, so we're now up to our third reaction. We are going to react 30 mils of thiosulfate solution, which we have measured out here, with, let's move these ones out of the way, we've finished with those, with 20 mils, so 30 mils of thiosulfate, 20 mils of water. Mix that one together. Okay, we have our 5 mils of hydrochloric acid ready to go. Put this one in first, ready. Okay, see if I can do better than last time and record this as soon as I put it in. Okay, we're just going to wait until the cross disappears again. Can't actually see any cloudiness appearing yet. I can see it just starting to precipitate now. It's getting that milky look about it. Can still very clearly see the cross. Still can see the cross and not. Okay, So that was our third reaction. Our time for that was 34 seconds, 34.96 that is. So that's our third reaction. We have 2 more reactions to go before we can start making some conclusions about what patterns we've seen in this experiment. Okay, up to reaction 4 now. We have 20 mils of thiosulfate solution, and we are going to dilute that with 30 mils of water. So we've got 30 mils of water. Pour that in. Okay, then we'll transfer this to the conical flask. Okay, and we have our 5 mils of hydrochloric acid, and we're going to add that and observe. Just observing the cross again, waiting until we can't see it anymore. I'm not seeing any cloudiness yet. Very slight cloudiness at the moment. It's developing. Much cloudier now. Still can very clearly see the cross. Okay. Almost can't see the cross. Still can. And can't. All right, that's 57 seconds, or 57.93. So that's our second last reaction. Okay, we're on to our last reaction for this experiment. We have our 10 mils of thiosulfate solution, and we are going to add 40 mils of water. Think about what you'd be expecting from this reaction, given the pattern that we've started to see. Okay, so we'll add our thiosulfate to our conical flask. Remembering what this equipment's called, this is our measuring cylinder. This is a 100 ml measuring cylinder that we've had our thiosulfate in, and with our water we've had that in a 50 ml measuring cylinder. You'll need to write down the materials list for this practical. And in our 10 ml measuring cylinder we've measured out 5 mils of hydrochloric acid, which is at a concentration of 2 molar. Again, we're going to pour the acid in and observe to see when the precipitate is what can we call it, crowded in that solution that we can't see the cross. Okay, we started our stopwatch. Can't actually see any cloudiness yet. I think we might be getting some precipitate forming at the moment. It's just getting slightly cloudy and more so. Certainly getting more and more cloudy, but we can actually still see the cross. very faint now. I think we'll call that almost unable to see the cross there. Still can just see it. We're at 2 minutes 44 now, so it's a lot slower than we had earlier. Okay, stop. Okay, just to recap what we've done in this experiment. We have been looking at the effect of the concentration of our sodium thiosulfate solution and looking at the reaction time when we react the sodium thiosulfate solution with some hydrochloric acid to form sulfur, which was our precipitate. So the reason the solution went cloudy was because the sulfur was forming in the solution, and we had our cross underneath the flask, and we were doing a measurement to see when it was that we couldn't see that cross anymore. Just to recap on the independent and dependent variables. So the independent variable that we were changing was the concentration of the thiosulfate solution. So remember, we had thiosulfate solution in a flask, and we diluted it, apart from the first one, which we did nothing to. We diluted it with some water. So we made lesser concentration of the thiosulfate solution as we went along. We always use the same amount of the acid. We reacted the two together, and we measured how long it took before the precipitate was forming so much that we couldn't actually see through the solution, through the bottom of the flask to where the cross was that we'd drawn on the tile first up. We measured the time. So our dependent variable, the reaction rate, is the time it took for that to happen. What year 10s you're going to be doing is to be writing a method for this practical. So I'm just going to run through like the equipment. Obviously this is here for me to be filming the reaction rate for you. We've got our sodium thiosulfate solution. In your document that goes with this practical, you'll have the details of its formula and how you spell its name and so forth. It was 0.2 molar. So 0.2 molar tells us how concentrated that solution is. How many particles of sodium thiosulfate is there in that aqueous solution? Aqueous just means water. We had 2 molar of the hydrochloric acid, which we reacted with that. We always used 5 mils of it in our flask, our measuring cylinder, sorry. So, equipment, white tile, stopwatch, conical flask. We needed a texter to draw our cross on our tile. We've got a heat-proof mat here just to make sure we didn't make too much mess on the bench. We have the 10 ml measuring cylinder to measure our acid in. We have the 50 ml measuring cylinder to measure our water in. And we have the 100 ml measuring cylinder to measure our sodium thiosulfate in. And I think that is all I need to explain to you. So if you look at the videos that we'll attach for you with your document, and then you're going to be starting to make up the method and obviously doing the materials list before you then go and analyse the results. Thanks. Have a great day.